Good morning and welcome to the video for Thursday, August the 6th. This is going to be a video for upcoming third graders, and this is the last video of this set of summer videos. Today we're going to look at how to identify or describe four-sided shapes, quadrilaterals, or three-sided shapes, triangles. And so we'll start with our quadrilaterals, and all of our quadrilaterals are going to have four sides and four angles. So this one right here, it may not look like there are four angles here. We've got 1, 2, 3. The fourth one actually counts as being this angle right here. We'll worry about that more as we get into closer to 5th and 6th grade with how we would measure that. So we have technically four different kinds. There is a chance for a quadrilateral to not meet any of these requirements, but we won't cover that today. So a trapezoid is going to have at least one pair of opposite sides that are parallel. So this would be that pair here, and this pair would be for the center. And then we have a square. So we actually have two pairs of sides that are both the same length. For a rectangle, we have two pairs of opposite sides that are parallel. So our top and bottom and left and right are parallel to each other. And then we have two pairs of sides that are of equal length. And so my top and bottom sides are the same length. My left and right hand sides are the same length, but they're not all the same length. Not all four sides are the same length. And then we would have four right angles. And you'll notice we have a square here. A square is actually going to meet all of the requirements for every single way that we can describe a quadrilateral. So we're going to have two pairs of opposite sides that are parallel. We're going to have four sides that are the same length, and we are going to have four right angles. A rhombus is going to have two pairs of opposite sides that are parallel and four sides that are the same length. So let's take a look at some of our examples. If you want to pause the video, I'm going to take a look at number 4, number 6, number 7, and number 9. So if you want to pause the video and see what you come up with at home for these, and then when you're ready, hit play for that particular number. So number 4, we have four sides. The top and bottom sides are the same length, the left and right sides are the same length, but it looks like they're different lengths. We have four right angles, so we're definitely going to have a rectangle. We can't have a rhombus because we would have to have all four sides the same length, which means we also don't have a square, but we do have a trapezoid. So again, our requirement for a trapezoid is that we have to have at least one pair of parallel sides, and we have two. For number 6, we have one pair of parallel sides. There are different lengths. So actually, I probably shouldn't mark that this way. We normally put those markings to show that they're the same length. So I'm going to have a trapezoid. I'm going to have a quadrilateral because it's a four-sided shape. And then I'm not going to have either a rectangle or a rhombus. For this one, I am going to have a quadrilateral. I do not have a pair of parallel sides. So I can't have a trapezoid. I don't have any right angles, so I can't have a rectangle. But I also don't have any pairs of parallel sides that are the same length. And then same thing for rhombus. So this is just going to be a quadrilateral. It's not going to be any of the other descriptions that we might use. And our last one, we have a square, which means we also have a quadrilateral, we also have a rectangle, and we also have a rhombus. So now let's look at triangles. There are two different ways that we can describe triangles. The first one has to do with the measurement of the lengths for each side. We're not going to describe those using like isosceles or scaling triangles until we get into 4th grade, but we will describe the size of the angles as well. And so we might say that a right triangle is going to have a right angle. An obtuse triangle is going to have an angle that is greater than 90 degrees, And then an acute angle, which would be smaller than 90 degrees, an acute triangle would have 3 of those. So using that information, let's go ahead and take a look at our 3 examples here, or 3 for each one, and see which ones work. And so for our one on the left, no sides equal length, that looks like that one should go over here. 2 sides of equal length, that looks like it would be this one. And then 3 sides of equal length would be this one. Usually if we have 3 sides of the same length, we are also going to have 3 angles that are the same length or measurement as well. So one angle is a right angle for the bottom. That looks like that one should go over here. One angle is greater than a right angle, and so that would be this one here. And then our angles less than a right angle. If we have an acute triangle, we have to have all 3 angles smaller than a 90-degree angle or right angle. And we'll talk about more of why that is at some point, although you won't have to learn it specifically until we get into 4th grade. And now we've got one more set of things to look at. So triangle M is going to have our right angle, and it looks like this side and this side are the same measurement. This one would be different. Once you get into upper grades, 5th and 6th grade, I think specifically 6th grade, you'll learn exactly how to find the length of that particular side. So now we want 3 angles that are less than a right angle. That looks like that would match K. And we would have 3 sides of the same length. And for this one, that means L is going to be our one that's left over. Here would be the angle that would be larger than 90 degrees. And then it looks like both of these could be close to the same length, but it actually extends farther out this way. So we're not going to have any sides of equal length. So that finishes everything I want to talk about for today. Just to give you an update on what's heading down my path for recording videos and so forth. As we go back to school, whether you're staying at home and learning remotely or you're coming into the physical building for daily classes, I will be live streaming the classes, but I will also be making videos that will be online. So those will be in Google Classroom. We're working with the Bitmoji slides and so forth. So there will be a slide for math each day that will have some different things, including a link to the live stream if you're at home. But then I'm also going to be doing a quick, like maybe 2 to 3 minute homework help video for every single lesson. And I'm actually planning on doing that even after we're through all the COVID-19 stuff and are back in the building every single day. The reason for that is if you have math at 9 o'clock in the morning, and then you don't get to do the homework until 4:30, 5 o'clock at night, you might not exactly remember every single thing that happened when only your math homework page is going home. So the idea is I'm going to have a quick video to kind of refresh what we worked on. That helps the parents understand what we're working on, as well as the students. So if they need any additional help, the video and or assistance from parents can help them remember what we were working on that day. Hope you have a great summer. I'm looking forward to seeing everyone either in person or online over the next, oh goodness, it's going to be another week or 2, I think, before we start trying to get everything situated for the Tell the Teacher days and so forth, where you can come by the school and visit and meet everyone. So hope you have a great rest of your summer. I look forward to seeing you in person or online in the very near future.